Okay, so let me continue with the slide. Sandwich composite. The main reason for using the sandwich composite is to reduce the weight, while we can enhance the acoustic damping, thermal insulation, and impact absorptions. So we can use sandwich composite to fabricate the secondary aircraft structures, like for example ailerons, flaps, engine nacelle, floor panels, subject to bending loads. Because you know that the sandwich composite has the honeycomb core, which can withstand the flexure. How can I say? Had this structure had good flexure strength, and therefore is have to increase to prevent the bending or the failure from how can I say, from buckling. Yes, and this is the reason we use the sandwich composite instead of the laminate composite in order to withstand the bending load. Yeah. And this is the main reason for that the sandwich composite can be used to fabricate the floor panel. Mhm. And several, how can I say, parts inside an airplane that can be fabricated by the sandwich composite, as for example random mesh, noise landing gears door, yeah, main landing gear doors, and so on. Yes, so you can see from here, this is the different parts of the airplanes which are made of sandwich composites. And whether or not we have already produced sandwich composite, yeah, I do not know. For the moment, the case in Vietnam. Sandwich composite, yeah, we have already discussed. We have a face skin. This is a thin sheet of fiber polymer laminate. For example, the carbon fibers reinforced epoxy resins composite can be used to fabricate the face skin. The core, the core can either be the honeycomb, corrugate, foam, monolithic cores. And we mainly use the honeycomb structures for making the core of the aircraft sandwich. So for the honeycomb core, this is actually thin sheets attached to form the connected shell and look like the nest of the bee. Yeah. And there are two most common configurations, as hexagonal and rectangular. Hexagonal above and rectangular below. And aluminum alloys are the main material that can be used to fabricate the honeycomb core. So we have a 5000 series or 2000 series. So for example, 5056 treated by S39 or 2024 treated by D3. Nomex can also be used to fabricate the honeycomb in the aircraft sandwich. So Nomex is a straight name of aramid fibers, paper in phenolic resins, which can help to provide the high shear stiffness to the honeycomb. And we use the sandwich composite in order to balance properties of face skin and core. I'm sorry, which I mean that in the sandwich composite, we need to balance between the mechanical of face skin and core. And in order to have the high structural efficiency, because each one will be responsible for a certain function. For example, core must have sufficient shear and compressive strength to ensure the effective support of skin. Whereas for the skin, we need the stiffness and strength skin to provide high tensile and compressive properties to the composite. And because when you study the strength of the materials, and when the sandwich structure is subject to the bending load, so the upper layer below the neutral axis will be subject to the compression load, and below will be the tensile load. And in between the layer of material, we have the shear load as well. And therefore, the core must have sufficient shear and compressive strength. Yeah. to ensure the effective support of skin. Yes, because the core we are the main factor that withstand the bending load. Yeah, and whereas in case of the scale, we need the stiffness and strength scale to provide high tensile and compressive property to the composite, because the above layer under compressive load and below layer being under the tensile load. When the sunwick composite is subjected to the bending load. So that's what we have discussed. And so now we are at the slide 32. But let me show you as I remember. Where is it? Here. So above skin, we have compression load. And in between the skin and core, we have the shear load. Another skin is subjected to tension load. Yeah, that's what I have mentioned. And now we can discuss on the environmental durability of composite. So there are several factors that will be focused on. So for example, first, moisture absorption of composite. It depends on actually the operating condition of the aircraft. So if it exposed to the environment having the high humidity and warm temperatures, so it will increase the rate of moisture absorption. And in the chapter 4, we have discussed about the degradation of polymer. And under this condition, high humidity and warm temperatures promote the degradation physically, chemically, and mechanically properties of composite over the time. Or we can say degrade physical property, chemical property, and mechanical properties of composite over the time. And high growth thermal stand for the wet and hot aging, yeah, hydrolysis and thermal. Yeah. For aircraft parts, yeah, the deep parts on the aircraft can also be affected by various fluid. Can be the fuel, can be the coolant fluid, can be the how can I say, coolant fluid. Yeah, different kinds of oils, additive. Yeah, I forgot hydraulic fluid. Yeah, and by the light, yeah, UV radiation. And concerning the absorption of moisture, we have the diffusion of water molecule through the polymer matrix or along the fiber matrix interface region. Yeah, until reaching the full saturation, nghĩa là cái sự khuếch tán của các cái nguyên tử nước thông qua cái polymer matrix hoặc dọc theo cái mặt biên giới giữa cái pha polymer là pha nền và cái sợi vật liệu gia cường, đúng không ạ? Và cái việc khuếch tán như vậy thì nó sẽ kéo dài cho đến khi nó rơi vào trạng thái bão hòa. Và cái tốc độ của cái việc khuếch tán đấy thì đương nhiên là tỷ lệ với cả nhiệt độ, tỷ lệ thuận với cả nhiệt độ. Bởi chúng ta biết là các cái phân tử của nước mà nó nhận được năng lượng tự do thì nó rất là hoạt động và nó dễ di chuyển đến khuếch tán đến những cái vùng có nồng độ thấp, khuếch tán từ nơi có nồng độ cao đến nơi có nồng độ thấp. Và cái tiếng Anh Mỹ. Yeah. Carbon and glass fiber do not observe moisture. Organic based fiber like the Kevlar fiber can absorb significant amounts of moisture. So different materials, yeah, behave differently, of course. And most polymer matrix can absorb water. So for example, the polyether ether ketone can absorb smaller than 1% on weight of water, while the phenolics can absorb more than 10%, and epoxy resin can absorb water within the range of 1 and 4%. And on the right side, you see the graph showing you the relationship between the absorbed moisture as a function of square root of time. Yeah. So yeah, when the time increase and the moisture, the degree of moisture absorbed to the surface is higher, but up to the saturated point, up to the saturated point là đến một cái giới hạn, cái vị trí, một cái điểm bão hòa nào đó thôi. And of course, when we increase the relative humidity and the degree of moisture absorption, we increase, of course. And the similar effect can be observed with increasing the temperatures. And by increasing the temperatures, and therefore the degree of moisture absorption will be increased, directly proportional. So easy to understand from a point of view. Yeah, depending on the versions, some will require you, the other no. Environmental durability of composite. We also consider the combination effects of moisture and the UV light on the physical and mechanical properties of the composite, of course. First is the plasticization. This means uh, to become more ductile or hóa dẻo. Is the effect of losing stiffness and strength in the epoxy used in the aircraft composite. So if we increase the temperatures and we consider the carbon fiber reinforced epoxy composite in dry conditions, and we can reduce the open hole compressive strength. So for example, the moisture reduced the matrix dominated mechanical properties around 10% for the subsonic aircraft and around 25% for supersonic aircraft. Có nghĩa là cái hơi ẩm nó sẽ làm giảm cái tính chất, mà cái tính chất này đem lại chủ yếu bởi cái tính chất của anh nền polymer ấy. Thì trong cái trường hợp mà xuất hiện cái hơi ẩm này thì những cái vật liệu composite nào mà cái tính chất nó phụ thuộc nhiều vào cái anh matrix ấy, thì nó sẽ bị giảm cỡ khoảng 10% cho những cái máy bay bay với tốc độ dưới siêu âm, dưới tốc độ âm thanh thì đúng hơn, dưới tốc độ máy bay siêu âm, dưới cái siêu âm, và trên 25%, cỡ khoảng 25% với máy bay mà trên tốc độ đó. Thường nó liên quan đến tốc độ âm thanh. Polymer matrix and water can promote more severe form of degradation, which leads to the chemical change by hydrolysis or chain season reactions. Chain season reaction is mean that we have the polymer chains which can be cut into the smaller chains, which mean that we reduce the properties of the polymer. And this behavior is irreversible. Go in this direction and cannot go back. Irreversible. And when the material is absorbed moisture. So the moisture will be, or the water molecule will be diffused to the area in between matrix and the reinforcement, and this creates the swelling and wrapping together with cracking of composite. Swelling là sự nở trương ra. Bởi vì chúng ta biết là khi mà có cái polymer matrix mà nó kết hợp với cả nước thì cái nước mà được hấp thụ vào ấy, nó sẽ hấp phụ thì ở trên bề mặt hấp thụ nó đi cả vào trong nữa, thì nó sẽ làm thay đổi cái tính chất về mặt hóa học bởi cái hiện tượng điện phân, thủy phân, và nó có thể tạo ra các cái phản ứng mà cắt đứt các cái mạch polymer chính. Và chúng ta biết là cái tính chất của polymer thì nó phụ thuộc nhiều vào cái chiều dài của cái sợi polymer đó. Nó càng dài, đúng không ạ, thì nó sẽ càng bền, đúng không ạ? Bởi vì polymer của chúng ta vốn dĩ là hợp chất cao phân tử, nó càng dài thì nó mới càng bền. Ví dụ như là high density polyethylene chẳng hạn thì nó sẽ bền hơn là polyethylene. Nhưng mà cái việc mà khi mà hấp thụ vào rồi thì nó là một quá trình không đảo ngược, đến là nó chỉ có bị phá hủy thôi. Và khi mà cái vật liệu này nó hấp thụ rất là nhiều cái hơi ẩm thì nó sẽ bị trương nở ra, nó sẽ bị cong vênh và nứt cái vật liệu kết hợp composite của chúng ta. And moisture absorption lead to the formation of problem for open cell sandwich core composite. Because the moisture is diffused through the skin to form the water droplets within the core and soften or corrode the aluminum honeycomb. Yes. So this is the negative effect of moisture absorption, of course. And trapped water. For example, if we have, for any reason, the water is trapped inside the, polymer-based composite materials, and at high enough altitude. So we know that at, for example, 10,000 meters, and the airplane fly at speed of, let's say, 1,000 kilometers per hour, and the temperature outside is minus 50 degrees C, and therefore the temperature can be freeze. And this creates a serious issue because the water expand really. When freezing, the water expand and create a tensile pressure on surrounding composite. Yes, I have to check again with this, because basically when we heat up and this can be expand. Yes. Yeah, and this one I have to check again with the textbook. And the problem is that at the high enough altitude and water trap tend to create the crack caused by the material delaminations. So whether or not the water expand, I have to check. Yes, and inform you later on. For the surface of composite can be degraded by the UV light. So because the UV light, ultraviolet light, destroy the chemical bond in the epoxy resin, and if you want to avoid this UV degradations of the composite, we can dope polymer with the UV absorbing compound, or using a certain kind of paint which can absorb the UV light in order to minimize the damage caused by the light. Yes. And basically, for example, if you have the bowl, let's say, which is made of composite material, which made of polymeric materials, and you expose to the sunlight after, let's say, 3 months, and it's become yellow and is more brittle because the UV light break the covalent bonds and make it more brittle. Yes. So in order to prevent or to reduce the negative effect of UV degradation of the composite, and we can dope the polymer with the UV absorbing compound or using the pen to absorb the UV light to minimize the damage. Yeah. Okay. The other type of composite is metal matrix composite. So we have already discussed the polymer-based matrix composite. Polymer-based matrix composite using polymer is the main materials and reinforced with the, for example, carbon fibers and the other fibers. Metal matrix composite using metal as the matrix materials of the composite. And metal matrix composite is lightweight structural materials, but it have few application in the aircraft, helicopters, and spacecraft. Yes, there are some situations that people use metal matrix composite to fabricate the structural part of the airplane, but not many applications. So basically, and in general, it consists of hard reinforcement with the amount being smaller than 30%, 38%. And this reinforcement is distributed within the metal matrix phase. And the metal matrix phase can be made of, for example, aluminum, like 2000 series aluminum alloys, 7000 series aluminum alloys, or titanium aluminum 64. Or even we use the nickel-based superalloys to as the matrix for the composite, subject to work at high temperatures. And in order to reinforce metal matrix materials, ceramic or metal oxide can be used. And the ceramic or metal oxide can be reinforced metal matrix uh, in the form of continuous fibers, whisker, or particles. So I would like to say that I observe more frequent the reinforcement in the form of whisker or particular in metal matrix composite. So for example, uh, the titanium diboride particles reinforce the copper-based matrix, or yeah, the ceramic phase particle reinforce the aluminum matrix. Yeah. Rather than using the continuous fibers like in the case of fiber reinforced polymer composite. And the common continuous fiber reinforcement, we can say the silicon carbide coated with bore, the carbon fibers or silicon carbide fiber, and common particle reinforcements, for example, silicon carbide, alumina, or boron carbide. Regarding the properties of metal matrix composite, there are several points that we should focus on. For example, metal matrix composite have higher elastic modulus and strength, but lower coefficient of thermal expansion. Superior properties at elevated temperatures. This means that we have higher creep resistance, higher rupture strength, and few have better fatigue life and wear resistance than the base metals. Base metal is mean that the metal matrix. Metal matrix. Yeah. Sometimes we call metal-based composite, or sometimes we call metal matrix composite. So they have the similar meaning, or the same meaning actually. Metal matrix composite have lower density comparing to the base metals, but it depends. What are the base metals? What are the reinforcement in order to confirm whether we can lower the density comparing to the base metals? Metal matrix reinforced with continuous fibers having the anisotropic properties because is when we reinforce with the fibers. So the direction that we reinforce with fibers will have better properties comparing to the properties of material in the other directions. However, the metal matrix composite contains whisker or randomly aligned or the particle will have, let's say, the isotropic properties. And we have the isotropic properties of metal matrix composite when the whisker or the particle well distributed inside the metal matrix. Otherwise, we do not have isotropic properties. Metal matrix composite generally have low fracture toughness and ductility, and this means that this material has low damage tolerance. Yeah, and that is the main reason we limit the use of metal matrix composite in aerospace structures because they have low damage tolerance. Yeah. Còn cái này tôi muốn giải thích cụ thể hơn với các em là bởi vì nếu mà chúng ta tiến hành gia cường bởi các cái sợi, có thể là sợi silicon carbide chẳng hạn, hay là sợi bo ở trong cái vật liệu metal matrix composite ấy, thì đối với những cái dạng sợi dài và liên tục như vậy thì chúng ta gia cường theo phương nào thì nó bền hơn so với phương đó, đặc biệt là chịu kéo, dẫn tới là nó bền theo phương mà chúng ta gia cường nhưng lại kém bền hơn so với các phương còn lại, thì tính chất ở đây là tính dị hướng. Ngược lại, nếu chúng ta sử dụng các cái vật liệu gia cường là dưới dạng whisker, là những cái hình thù nó không theo một cái chuẩn nào cả, nhưng mà nó lại nhỏ dẹt và phân bố, thì một cách ngẫu nhiên ấy, thì trong cái trường hợp đó thì chúng ta có thể có khả năng tạo ra những cái vật liệu mà có cơ tính, mà có tính chất là tính đẳng hướng. Nhưng mà cái điều kiện để có cái tính đẳng hướng ấy, hoặc là đẳng hướng giả ấy, đó là các cái sự phân bố về whisker này và các cái hạt ấy là nó phải phân bố đồng đều ở trong cấu trúc. Chứ nếu như mà một cái vật liệu của chúng ta mà vì một lý do nào đó nó xảy ra cái sự phân tách, có nghĩa là những cái anh vật liệu gia cường nó về một góc, cái vật liệu nền nó lại chỉ về một góc thôi, thì trong trường hợp đó chúng ta sẽ không có cái được gọi là cái tính đẳng hướng đó. Lúc đó nó là gọi là khuyết tật segregation, có nghĩa là cái sự phân tách của cái vật liệu, dẫn tới là cái tính chất của các cái vùng khác nhau nó khác nhau, bởi vì cái sự phân bố về cái thành phần hóa học trong đó nó khác nhau rồi. So we can take a look at the diagram on the right side of this slide. The first one of both, we have the relations between the density change as a function of the silicon carbide reinforcement content. And basically, if the matrix is magnesium, and by increasing the amount of silicon carbide content, we can increase the density of the material. So this is unexpected thing, of course, because we want to reduce the density. Actually, we want to reduce the density. Yes. For the case of aluminum, yeah, there's no actually there's no significant change in terms of the density. But for the case of titanium or nickel-based superalloys used as the matrix materials, and if we increase the amount of silicon carbide content, and then we have the positive effect of density reduction. So the weight loss, yeah. So it's become lighter because we implement the lighter material to the matrix base, to the matrix, and therefore, yeah, within the an unit volume, and the density tend to reduce because we implement the elements having lower density to the base matrix, to the matrix. Yeah. And below we have the relationship between the tensile fatigue stress as a function of the cycle to failure, and the cycle to failure uh, how can I say, described in the logarithm scale. So all of them show the reduction of tensile fatigue stress as a function of cycle to failure, of course. But the aluminum matrix composite have a better tensile fatigue stress comparing to the monolithic aluminum, for sure. And now we can consider several applications of metal matrix composite. We know that metal matrix composite, how can I say, generally speaking, have a low damage tolerance, and therefore we limit the use of metal matrix composite in aerospace application, but we still find some uh, for fabricating the structure components. So, for example, the ventral fins of the F-16 using the ceramic particle reinforced aluminum matrix composite. So, specifically using 17.5% of silicon carbide reinforced with a 6000 series aluminum base matrix. And this material, the material that we have discussed, can also be used in the fuel access door cover on F-16 fighter aircraft. The metal matrix composite also used in main rotor blade sleeve of the Eurocopter EC-120 using particle reinforced aluminum composite. Yes, because when we use the particle reinforced metal-based composite, we can have uh, higher probability of fabricating the isotropic materials. So it's easier to fabricate, easier to synthesize the material with well distribution of the second hard phase within the matrix. If you use the fiber reinforced matrix, and then as a result, you will have the anisotropic properties. The metal matrix composite, if reinforced using continuous fibers, uh, were the case of the space shuttle orbiter. So they use the aluminum reinforced with 60% of both fibers. So it means in this case, ball is not really the reinforcement, and aluminum is not really the matrix, because matrix is the main materials. Yeah. But can be grouped as the metal matrix composite. And metal matrix composite have potential applications for the aircraft gas turbine engine. Yeah, potential. Yes, so it needs further development, yeah, to be able to guarantee that it has higher damage tolerance. And you could see that if we reinforce uh, the fiber, if we reinforce the aluminum matrix with the fiber reinforcement, and you can see that the young modulus in different direction will be different. In axial direction, will be higher than the young modulus in the transversal directions. So showing the anisotropic properties of the material reinforced by the fibers, the continuous fibers. And basically concerning the fracture toughness, by increasing the amount of silicon carbide particle content, and we reduce the ductilities. Unfortunately, some of the material become more brittle and have lower damage tolerance. Yeah, is the big issue, because we want to have uh, the materials behave or having good damage tolerance. So in case of the large forks, the part can be deformed but can function normally at least until the time that we land the aircraft on. So sorry for 1 minute. Okay, so where's it? Fiber metal laminate is another type of composite, but it can be considered is advanced composite. Yeah, can be considered as advanced composite. Fiber metal laminates is lightweight structures. Uh, yes, with the alternating thin layer having thickness from 0.2 up to 0.4 millimeters of meters. Can be the aluminum or titanium and we combine with the fiber polymer composite. So the layer of meters and the layer of composite and we join them together. So for example, on the right side, you see that we have the sheet of meters and we have a sheet of pre-preg, the resin pre-impregnate. Yeah, the fiber with resin pre-impregnate, meter, pre-preg, and meter, join them together. The most common fiber metal laminate in aerospace structure is glass. It's the brief name of glass reinforced fiber metal laminate. And this material actually contains the aluminum alloy sheet together with combined with a thin layer of glass epoxy prepreg composite. Yes, and it's actually quite expensive, which is 10 to 7 times more expensive than the aluminum alloys only monolithic meters. And the glass composite can be used for the upper fuselage, the leading edges, a vertical fin, and horizontal stabilizer of the Airbus 380 aircraft. Can also be used for making the cargo doors of the C-17 Global Master 3. And we have another applications. If the fiber laminate is called ARA, another type of fiber laminate. Fiber metal laminate is ARA. This is the aramid aluminum laminate, which composed alternating sheet of aluminum alloy and aramid epoxy. This is actually the aramid fiber reinforced epoxy resin composite. And the ARA has exceptional impact resistance and damage tolerance. However, this material is limited use in aerospace structures because we also have the moisture absorption problem. Several properties of fiber metal laminates I can discuss here. For example, glass, or we can say fiber metal laminates, lighter than the equivalent monolithic metals because we implement with the organization fiber polymer composite. Yes, combined with the metal. So fiber polymer composite is lighter in general comparing to the metals. Yes. The density of the, for example, carbon fiber reinforced epoxy resin is 1.6 rho gram per centimeter cubic, whereas in the case of aluminum, poor aluminum is 2.7 gram per centimeter cubic. And therefore, when you implement the composite to the structures of metals, and therefore you can reduce the weight of the composite material comparing to the monolithic metals. As a result, you can significantly save the weight, for example, in the Airbus 380. Higher tensile strength, yeah, I mean the fiber metal laminates have higher tensile strength, higher damage tolerance, because we have the present metal, monolithic metal here, the sheet of metal here. Impact strength, fatigue resistant than the monolithic metals. And if we consider the fatigue crack growth in the glass, this is around 10 up to 100 times slower than the monolithic aluminum alloys, so which is prolonged. It has the ability to prolong the fatigue life of the material, so it's good. We can increase the cycle to failure of the materials, of the part. And the fiber metal laminates has the possibility to tailor the structure properties. It means that we can adjust the number of layers, the type of prepacked layer, the alignments of the layers, and so on. So we can adjust, we can customize the fiber metal laminates according to the specific application. Yeah. And using the fiber metal laminate can reduce the pitting corrosion, reduce the stress corrosion cracking. And what is the pitting corrosion we can study in the next chapter, chapter 6, where we, what can I say, investigate a little bit concerning the corrosion in metallic materials. And reduction in the pitting corrosion of glass with respect to the monolithic aluminum in the aircraft structures. And last but not least, glass has higher fire resistance due to the low thermal conductivities. Yeah, it's yeah, roughly under the presence of the composite, which can prevent the heat from transferring to the another layer. But the polymer composite itself cannot withstand high temperatures. Hmm. Okay, another type of composite, or another type, yes, actually, the ceramic-based composite is the ceramic-based composite. The ceramic-based composite is used for improving the tensile strength and toughness of conventional ceramic materials, whereas it can maintain the lightness, high stiffness, corrosion resistance, wear resistance, and thermal stability. The ceramic matrix composite is composed of ceramic matrix face and the reinforcement. The reinforcement can be in the form of fibers or whisker. And generally speaking, the strength and toughness of the ceramic face is too low for the use in aerospace structures. The structures, yeah, but enough for use in the likely loaded aerospace parts requiring thermal stability, for example, the braking pad. Yeah, for example, like this. The ceramic matrix composite is high resistant against the thermal shock because it's thermal stable. Yeah. And the ceramic matrix composite resists to cracking and failure when rapidly heated and cooled the, the part or the structures. This material can survive for a long time at the temperatures well above the melting temperatures of the superalloy, can retain the stiffness and strength together with toughness properties at about 3000 degrees C. That the nickel-based superalloy cannot withstand, of course. Most often used, yeah, the ceramic matrix composite is mostly used in aerospace, for example, the silicon composite, silicon carbide composite, glass ceramic composite, carbon composite. Yeah, yeah. I would say that studying the glass and ceramic is a field within the area of material science and engineering. Polymer, yeah, is a field as well. So it's not a course; it's the field of study. Yeah. Metallurgy is a field of study. Material characterization is the field of study, and even biomaterials. Yes. So yeah, we need to know about the concept, but generally speaking, nobody knows everything. And below you have the table summarize the effect of silicon carbide reinforcement fibers on the bending strength and the fracture toughness of ceramics material of several ceramic materials. So for example, silicon carbide, you have the flexible strength, uh, or you can say the bending strength, 500 megapascal, and the fracture toughness of 3 megapascal per uh, square root of meter, and so on. Yeah. So I think probably is probably enough for today. And next week is the last week for the course of aerospace materials, and I just would like to spend a little time today to discuss with you about the course and the final examination. For the course, I will try to go through the content of the chapter 5 and chapter 6. But as I already mentioned to you, we do not focus so much on the investigation regarding the uh, micromechanic and macromechanic of composite. Yeah, but I will introduce to you these parts, but not go in detail about the micromechanic and macromechanics of composite. Micromechanic, yes, we can discuss more, but macromechanics, yeah, you can read at home if you like. And for the last chapter 6, we discuss on corrosion, and and corrosion can occur in different materials, not only in metals, but can also in another type of materials like uh, polymer. Polymer can also be corrode, can also corrode. Yeah. But as I already mentioned to you from the chapter 2, many structural components are made of metallic materials, and therefore it would be better if we consider the corrosion inside metals. And within the chapter 6, we discuss mainly on the corrosion in metals. And if you have enough time, and if you are interested in, you can find more information on corrosion of other type of materials. And similar to the case of additive manufacturing costs, yeah. when the course is finished, and you should count the time for preparing the final assignment. I would recommend you to prepare the assignment before, not until the time that the course finishes. I do not know. It depends on you. And just spend enough time on preparing the assignment and try to understand the the selected paper that you have choose, and try to explain what you understand or what you understood regarding the paper, and write them down. Write what you understand down on the assignment. Because if you imitate the work of the others, and during the exam, I will ask you the question, and yeah, everything will be exposed. Okay, so it's the time for me to check attendance as usual, as usual. And if you have any question regarding the lectures or the assignment, you can ask me. Yeah. In between 1 past 3 and 35 past 3. Yeah. And for those who do not have any questions and others, thank you for paying attention to the lectures, and goodbye. Vâng, mời em.
Dạ cho em hỏi cái đề tài của mình của em á thầy.
Ừ.
Là của em là nó kêu là dựa vào phát triển vật liệu cho cái in 3D á, là nó rõ hơn là sao thầy? Kiểu em tìm cái đề tài nó sẽ có nhiều kiểu như là in cái cấu trúc thép bằng bằng in 3D, chứ mà còn cái mới tìm là cái gọi là sao? Cấu trúc vi mô và cơ học của vật liệu thép mới cho cái Y-Ax in 3D.
Ừ. Em đang hỏi về môn vật liệu hay hỏi về in 3D nè?
Dạ môn vật liệu thầy, tại vì cái đề
Ok.
em. Dạ.
Rồi. Có nghĩa là cái vấn đề của em là tập trung vào thép đúng không? In 3D
Dạ.
và in thép đúng không? Đúng
Dạ.
rồi. Thế thì cái bài báo mà em lựa chọn sẽ thứ nhất tập trung vào cái vấn đề vật liệu thép. Vật liệu thép này được tạo thành bởi phương pháp in 3D, thì có những cái yếu tố gì cần phải chú ý trong cái quá trình in, đúng không nhỉ? Và cái tính chất của vật liệu sau quá trình in nó là như thế nào, có những cái điều gì phải chú ý. Và trong một cái bài báo thì thông thường người ta thường là sẽ hướng đến một cái vấn đề là gap knowledge, có nghĩa là cái vấn đề mà về mặt kiến thức mà chưa người khác người ta chưa đụng vào, thì cái bài báo đấy nó sẽ giải quyết được cái gap knowledge đó. Thế thì em phải chỉ ra cho cái người đọc hoặc là cái người review báo chẳng hạn thấy được rằng là gì, cái bài báo của cái tác giả đó nó tập trung nó giải quyết được cái vấn đề cụ thể nào đó. Thế còn cái trình tự giải quyết thì em cứ đi theo cái trình tự của bài báo cũng không sao cả. Thường thì bao giờ người ta cũng giới thiệu để người ta thấy rằng là thế giới người ta đang làm như thế thì nó có một cái gap knowledge là gì, thì bài báo của chúng tôi sẽ tiến vào giải quyết cái gap knowledge đó. Đấy, sau đó thì ở các cái bước tiếp theo đó thì người ta sẽ giải quyết. Vậy giải quyết như thế nào thì em phải đọc bài của người ta, em hiểu như thế nào thì em giải thích lại vào trong cái assignment như thế. Tiếp theo là kết quả người ta đạt được, và cuối cùng là những kết luận liên quan đến bài báo. Thì nhiệm vụ của các em là tóm tắt lại. Vấn đề là tóm tắt này, các em phải phân tích trước, các em phải đọc bài báo này, các em phải phân tích, em hiểu bài báo, sau đó các em tóm tắt lại. Thì đến lúc mà tôi hỏi các em câu hỏi thì tôi sẽ hỏi liên quan đến cái bài báo và hỏi liên quan tới cái nội dung ở cái phần overview đấy. Bởi vì của em là liên quan đến thép đúng không nhỉ, thì tôi có thể hỏi một câu nào đó liên quan đến thép và thuộc cái phạm vi chương trình mà tôi đã dạy các em ở trên lớp, thế thôi.
Yeah.
Thế
Nên
còn nó không bó buộc vào các em phải làm gì cả.
dạ.
Ừ.
Tại vì cái đề em tại lúc mà em đọc á thì nó kiểu
Ừ.
như là thiết kế một cái vật liệu cho in 3D chứ không phải là gọi là cái gì gọi là phân tích mà cái cấu trúc của thép khi mà in 3D á thầy.
Em có thể làm bất kỳ cái gì cả, thiết kế
Dạ.
vật liệu cũng được, phân tích cấu trúc cũng được,
Dạ.
làm bất kỳ cái gì cũng được, miễn nó liên quan đến thép và có liên quan đến in 3D
Dạ.
là em đạt được mục đích của cái yêu cầu của cái người đưa ra bài rồi.
Dạ.
Đúng không?
Dạ rồi, cảm ơn thầy.
Không có gì.
Dạ, chào thầy.
Chào em.